Section 3.3, Math 103, telling about the difference in population mean using independent samples. On the previous video on 3.1 and 3.2, I kind of explained about the main difference and what formula to use. This one is continuation of that one. Here they are talking about the standard deviation of the difference is equal to that. This is a formula that just for your information, but we don't really use it for the problems here. But then at the bottom here, so if the original claim indicate that mean of population, the first one is equal to mean population of the second one, then the difference is always equal to 0. It's like 5 equal to 5, 5 minus 5 equal to 0. Or if the claim is mean in population number 1 is greater than population number 2, that the difference is greater than 0, and so on. So this is a formula that we use, and we understand that this part is always equal to 0. And this is a formula for DF. We discussed this before. And I understand that if I use the calculator, so I don't have to worry about this formula anymore because the calculator would actually give me a number. And this is dealing with the same formula. But the condition is the samples for difference in population mean for independent samples, that the samples are independently selected. So the both are independently selected, and they are random samples. And then the number of samples must be greater than 30 for both populations. Or both population distribution are approximately normal. So one of these two or both. Now, this is one example that is on the textbook. A frog jumping competition describing a short story written by Mark Twain, inspired by real annual content. So here, the numbers that are given on the next page. So there are two populations, and we take a sample from these two populations. One population is rental frogs, the other one is professional frogs. So we are taking 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 samples of each. Most of the problem that we have discussed, we already give you when we take samples, we give you the mean and the standard deviation. But sometimes with a problem like this, you need to calculate that yourself. Means you need to, for all these numbers on the top, you need to calculate the mean and the standard deviations, and also for these numbers on the bottom, you have to do the same thing. So what you could do is easier if you use your calculator, because the calculator will just go ahead and do all this for you. So what you do is you just go ahead and you edit. I already did that. You put all the numbers, the first row, you put it on L1, and the second is L2. I think because of the light, it's not very clear right now, but you could actually see. You put all the numbers in L1 and L2, okay? So when you do that, then I put a page here for you. In this page, I kind of summarize for independent and dependent sample. Since section 13.3 is just dealing with independent samples, so we are using one of these two formulas. If we are asking you to find the t, then if you want to use a calculator, you just use 2 sample t-test. But if we ask you to find the confidence interval for 2 independent samples, then you're using this one. So the difference is, this is 2 sample t-test, this is 2 sample t-interval, okay? This problem is dealing with 2 sample t-test. And rather than having x1 and s1, we already have all the numbers in L1 and L2, okay? So what you do is you just go to stat, test, and you go to number 4. And here, make sure you're in data, because if you put a stat, see, if you put in the stat, it just come up with a different number. So you put in data. When you put in data, so it goes to L1 and L2, means we ask calculator to go and pull all the numbers from L1 and L2. Now, which one of these three do we select? Remember, the sign, whether it's not equal or less or greater, is symbol of original claim. Okay, and original claim in this problem is the difference is less than 0. Less than 0, so here you're selecting the middle one, which is less. So in that case, you go to calculations. So what it gave you, the t, it gave you the value of p-value is 0.01, and t is minus 2.27 or 28. Okay, so and these are the numbers that you have it here. You see how you have the DF equal 18, and here the calculator will give you that. Give you DF 18. Okay, so that's how you work on that problems. And then here there is a lecture about what the pool t-test is. This is if you want to find a confidence interval. Again, I summarize it in this page. If we ask you to find a confidence interval, then you're using, if you want to use a calculator, you're using 2 sample t interval. Okay. And then the same condition again, samples are independent selected, blah, blah, blah. Like these problems, you already have all the numbers. And so all you need to do is just, if you want to use the hand calculation, you could see this is a hand calculation to find the interval. But you could also use the calculator to do that. So all the problems, all the homework problems in this section, we either ask you to find the interval like this one, and you could go ahead and use the formula. So I put this page before we're starting the homework problems. And again, as I said, section 13.3, we just use this to formula. And I kind of work on most of these problems using the formula. This one already has it. See, it has the long solution, but then at the end, I show you the calculator with just one line here. For all these homework problems, which I put a copy for you online. See, we just use that. And you understand when you do the calculation, the calculator would give you the p-value. If the p-value is less than alpha or significance level, you always reject HO. In these problems, your mean standard deviation and N1 for each population is given. And again, I'll show you all the calculation here in the bottom. So these are these problems. The claim, this is a claim. Mean motion for pitchers is less than mean for position players. So the difference is always less than or equal to 0. So this is a hand calculations that is type, and this is using the calculator. And this one is symbol of the original claim. All right, so this is another one. In this one, we are asking you to find the interval. Then you will use 2 sample interval. Okay, so I had it for most of this problem, not for all of them, because they all are very similar. So you should be able to do the problems.